Hello, good day everyone. Welcome to our comprehensive smart contract course. Whether you are a beginner or a pro smart contract developer, this course is your gateway to master sCrypt. So sCrypt is a TypeScript framework for writing smart contract on Bitcoin. When I say Bitcoin, I mean the original protocol, which is Bitcoin Satoshi version. So my name is Yusuf Idimina, and I will be your guide on this exciting journey. And also we will deep dive into the fundamental of smart contract, which is the backbone of any decentralized application and the blockchain ecosystem. So without wasting much of our time, let's look at how smart contract works on Bitcoin blockchain. So smart contract on Bitcoin are based on what we call UTXO model. So this UTXO model, UTXO stand for unspent transaction output, and each UTXO consists of some inputs and outputs. As you can see, we have inputs and outputs, and are also called locking and unlocking script. So the output contain the amount of Bitcoin and also the locking script, while the input, it contains the reference of the previous output and also the unlocking script. So an unspent transaction output is an output that is not consumed in any transaction, and also if an output has been used in a transaction, it cannot be used again. So a spent output is just like a corpse, like a dead body. Yes. An unspent transaction output, however, they are available to use in a new transaction as long as you can unlock them. So as you can see here, in the output we have a lock, and in the input we have a key. So if this key can unlock this lock, then you can actually spend this output. So think of it like a mathematical function, f of x. It will either return true or false. Also, I talk about locking and unlocking script. So a locking script is a constraint or condition that must be met before you can spend this output. And also the input is the condition that you will provide or you must provide for you to actually spend the output. So let me show you an example. So let me go back to sCrypt.io. Under documentation, let's go to how to write a contract. So as you can see, this is a simple contract, and this contract will be spent if you provide the sum and also the difference of this equation. As you can see, it is a smart contract. So this asset is regarded as the locking script because you must provide the sum and the difference of this equation, while this is the unlocking script, the argument that you will provide for you to unlock this contract. So this is a simple example of locking and unlocking script. Just consider this asset as an locking script because they are the constraint that you must provide, and this argument as the unlocking script. So this is about locking and unlocking script, and this is the official documentation of sCrypt. It is a very helpful resources to learn sCrypt. So before we proceed, let me show you all the requirements you need to start writing sCrypt smart contracts. So let's move on to installations. So your machine must have Node.js. It must be version 16 or higher and npm and git. Then you can install the CLI sCrypt CLI globally before you start writing the smart contract. So you can get the Node.js here whether Windows, Mac or Linux for your operating system. Yeah, so I already have mine, so you can install it. Simple. And after that, you must have Git, which you can also get it here and install it in your machine. And after that, you need to install the sCrypt CLI into your machine globally. So let me show you how to do that in my terminal. You have to run npm install -g sCrypt -cli. So by running this, you will install the sCrypt CLI globally into your machine so that you can easily create a new project, you can compile the contract, you can publish the contract, and even deploy and call the contract with the help of the CLI. So after installing the CLI globally into your machine, I already have the CLI, so let me cancel it. So after that, you can easily create a new project by typing npx sCrypt sCrypt -cli project, then the name of your project. So let's call our project demo, so it should be small later, demo like this, and run it. So by running this, you will create a new project by name demo. So let's wait for a bit. So as you can see, our project is being created. So we set up the project and set the project name, and we have successfully created the project. Then you can easily change the directory into your project folder, cd demo, then run npm install to install all the necessary dependencies, and also it takes a while. So if everything goes well, you will have a project like this one. So as you can see, it is demo, and under the source directory we have a sample smart contract, a script contract, as you can see, and a sample of text in the text file. So this is how a script project look like after after creation. So before we go further, let me show you something that is very important and will be very helpful to you in this journey. So let's go back to the documentation. So if you are new to Bitcoin development, please consider exploring these resources. They are very useful and helpful. So you can check the BSB Academy and took the BSB Bitcoin theory course. So this is it. The course is only 9 hours and contain 13 chapters. So it is very helpful for you if you are new to Bitcoin development. So these are the basics that you need to learn to start this course. And after BSB Bitcoin theory, you can check the Bitcoin essentials also, which is also very important for you to easily understand what smart contract on Bitcoin really are. So, and also you can consider exploring Satolan. It is very useful platform for learning the basic of Bitcoin. As you can see, they have wonderful documentaries. So these are the basics of Bitcoin that you should know for you to start writing smart contract on top of Bitcoin. And we are not going to cover the Bitcoin basic in this course, as this course is mainly for smart contract development with sCrypt on Bitcoin. So without wasting our time, we can easily move to how to write a contract, where we will learn how to write a smart contract on Bitcoin. So sCrypt smart contract is a class that extends the smart contract base class. So it, as you already know, sCrypt is a TypeScript framework for writing smart contracts. So sCrypt is an embedded domain-specific language. It is based on TypeScript, and it is like a framework that will help you write smart contract in a high-level language so that it can be compiled to Bitcoin script. So sCrypt is just a TypeScript, and a TypeScript code an sCrypt code is a valid TypeScript, but not vice versa. So if you are already familiar with JavaScript or TypeScript, so sCrypt will be very, very simple and easy for you. So let's start writing smart contract in no distance. So let's get our head dirty by writing a simple smart contract. So we are going to write this contract, and this contract is going to be deployed with a secret message, which is hash with SHA-256, and whoever knows the correct secret message can easily interact with our contract. So let's write the contract this way. Since a smart contract is an self-executing contract when some certain conditions are met, so we are going to make this condition that someone can interact with our contract by knowing the secret message. So let's write this. So we are going to, as I told you already, so a smart contract is a class, and let's call the name of our contract to be demo, and it extends smart contract base class. So we are extending the smart contract base class. So as you can see, we imported the smart contract base class from sCrypt library. So if you go back to the documentation and check it there, you also have a lot of information. So a smart contract is a class that extends smart contract base class. So as you can see here, so since our contract is going to be storing a data on chain which will hold the secret message, so there is what we call properties, and these properties are used to be stored on chain. So whenever you want to store something on chain, you have to use this property decorator. So it is as follows: add prof, then import it from sCrypt, as you can see here. Then let's call it hash, then it should be SHA-256. Let's import SHA-256 from sCrypt library also. So if you want to know more about properties, you can easily come to the documentation and under properties. So a smart contract have two kind of properties. There is a property that is stateful and stateless property. So this property in general, if you want to store something on chain, you can use the property. So as you can see, we are going to use this decorator to mark any property that intend to be stored on chain. So we are storing the hash message on chain, so, and it is stateless. So state means that whether we want to update this secret message or not. So if we want to update this secret message, we can easily pass in the true parameter into the property decorator like this. So this marks this property as a stateful property which can be updated in the subsequent contract calls. So here we don't want to update our hash message, so we will leave it stateless. So it is now stateless. It cannot be updated after deployed. So we are storing this on chain, and constructor, and this constructor will pass in the parameter of the property, which is hash, and is SHA-256, and there is what we call super. So this super, let's go to the constructor here. So a smart contract must have a constructor if it has at least one property that is not static. So we have a property and it is not static, So we must have a constructor, and also the super method must be called in the constructor, and we are going to pass all the arguments that are in the constructor into the super as well. So here we have one argument, which is the hash, and we are going to pass it to the super like this hash. Or you can just directly use sCrypt arguments. For example, in a situation whereby you have many parameters in the constructor, you can easily use these sCrypt arguments, so you don't have to type any argument into the super also. So after writing the super, you have to use this keyword, then this dot hash equals hash. Then we have already initialized them in the constructor. Then there is what we call method. So a smart contract must have at least one public method, because the public method is like main in Java or C. It is where we are going to be interacting the smart contract. So if you need more information about the method, you can always refer back to the documentation to learn more. So these methods, they are like properties. So these methods decorator, they can be used, as you can see here. Just if you didn't put this method, it's just a regular TypeScript method. So if you want a method that will be stored on chain and interact with the method on chain, so it must have this methods decorator. And we have two types of methods. We have public and non-public methods. Public methods are the one that you can interact with outside the contract, and the non-public methods, you can only interact with them inside the contract. So here we should have a public method. So method decorator, you can also import it from sCrypt library. So import it, and let's have a public modifier so that we can interact with it outside the contract. So let's call it unlock, and the name of this method is unlock, and we are going to give in the argument to provide the unlocking script for this contract, where a user will provide a message that will be compared with the stored hash message. So let's call it message, and let it be byte string. So let's import byte string, and it doesn't have any return type. So we are going to assert. This assert means that it's like a require statement, and you can also import the assert from sCrypt library. So we are going to assert that this message, SHA-256 of this message must be equaled, so this message must be equaled, so let's to byte string, yeah, just like that. This SHA-256 of this message should be equaled to this dot hash, else write invalid hash. So this assert is like a require statement. We'll make sure that this SHA-256 of this message is equal to the SHA-256 of the secret message. So if they are equal, you can easily interact with the contract. If they are not equal, you cannot interact with the contract. So this is a simple way to show you how to use prop decorator, the constructor, and also methods, which are public and non-public method, and how to use assert. And also a public method must end with this assert statement. So now let's move on to data types. So we have many different of data types in sCrypt. There are three. We have basic data types. So let's say data types. So we have basic type, and we have user defined type, user type, and also we have domain type. So the data types that you will use in the props and methods should be restricted to some specific types. So on the basic types, the types that we can use in the prop and method decorators must be either boolean, which is a basic simple true or false, or big integer, or a byte string. So let's see how we are going to use boolean and byte string in a script. So for boolean, it is either true or false. So let's say it's done equals, or the data type, let's say boolean equals, let's say true. So this is where we use boolean in sCrypt. So this boolean is either true or false. It's just simple true or false. And we can also, let's mark this as boolean. So that's a boolean. Then we can use big integer. In basic data types, we have big integer, and this big integer is a number that has a suffix of n. It's a big number, and it must have a suffix of n. So for example, let number, let's say big integer data type equaled, let's say 333 n. So a big integer is a number that has a suffix of n, a big number that has a suffix of n. Then we can also use byte string in the prop and methods. So we can use byte string also, byte string. So let's data byte string equals blah, blah, blah. So these are some data types that we can use in the properties and also method. And we can also use number, but it is on some cases we can only use number in the pix array or loop. So in sCrypt, the only place we use number in method and property is either in pix array or a loop, because in sCrypt an array must be of pix size, so it must be C2C, a compile time constant. So for example, where we use number is for example in pix array. Let's say in the property we have an array, so it should be of type pix array. Then the type, let's say byte string, and let's say big int. It's okay to use big int. And also the size of the array, let's say 3. So this is where we can use numbers. You can see it is only 3. It doesn't have a suffix of n, so it should be a number. This is where we use number in prop, and also we can use number in method in either pix array or a loop. So after these basic types, we have user defined types. So these user defined types, they are data types that are defined by a user. And let's say type, this is how we create a user types. Let's say type, let's say human, and the code. So let's say height should be like big int, and width should also be big int. So this is a user defined type. and this is how you can define your own type. So the human is now a data type that you can use in either property or method decorator. So you can use it inside the method or at the property. So after that, we have domain specific types. So we have several domain specific types, and these domain specific types can be used where byte string is expected, but you cannot use byte string where those domain specific type are expected. So let's go back to the documentation to see what are those data types, domain specific types. So let's yeah, so this is it, domain specific type. You can see it there. So there are several domain types, and they can be used where byte string is expected but not vice versa. For example, like a public key, like a signature, RIPMD160 is public key hash, or address is an alias for RIPMD160. You can use public key hash is another alias for RIPMD160, or hash like SHA1, SHA256, or SIG hash types. So these are the domain specific types that can be used where byte string is expected, and this pub key represent the public key, and this address represent the address, and this pub key hash too also. So let's go and see how we can use them. For example, let's write a simple pet pub key hash contract. So this is how you can use some domain specific types. So let's write the contract. So class pet to pub key hash should extend smart contract. So at property, so we use for the, let's say, the address, we need the address, so let's call it address. So this is where we can use the address. Is a normal Bitcoin SB address, an address that you can use to receive Bitcoin address. So here we are using the domain type, the domain type address. So we are expecting a byte string, which is the address, an alias or RIPMD160 that is used to receive Bitcoin. So then let's go to the constructor. I'm just showing you how we can use domain specific type. So we use one domain specific type in the property. I will show you how to use it in the method. So we have address and subtype address. So let's say SUFA and spread, sorry, address, and sorry, SUFA. We can pass in the address or argument as I told you. Then we can say this dot address is equal address. So we have an error, we put construction instead of constructor. I'm sorry for that. So we have a method to unlock the pet pub key hash. So this method is our decorator that we are going to store it on chain. Then it should be public. Let's call it unlock2, and here we are going to provide in the public key and the signature that can be used to verify the locking script. So we are going to provide the pub key. So here the data type must be public key, which is among the domain data type. So as you can see, we have pub key in the library. So this is it, and also the signature, let's say SIG, and we have also domain data type signature here from sCrypt. So as you can see here, these are the domain data types that we use where we are expecting byte string. So this is how it is. Then there are some remaining code, but the main issue of showing you this demo is to show you how you can use domain data types in the method and the property. So I hope you understand this.
then a loop. So a loop in sCrypt is bounded. What I mean by bounded, it must be specified in a compile time constant. For example, now let me show you how you write a loop in sCrypt. So let's say const maximum loop count, let's say 3, then for let's say I equaled 0, I is less than max, which is 3, then I plus plus, sorry. So this is how loop should be in sCrypt. It must be compile time constant. It has to be known because sCrypt doesn't support unbounded loop due to some security reasons. So a loop has to be this way. It's strictly this way. And after loop, let's look at how return statements are in sCrypt. So return statements are only valid at non-public method, and this is the only valid place for return statement. So a non-public method must have a return statement. So for example, now let's write a non-public method. Let's call it add. So it should also have method decorator. So let's say add, sorry, let's say add. Yes, so as you can see, it doesn't have a public modifier. Let's say a data type, let's say big integer. B data type should be also big integer. So then the return type, let's say it should also big integer, and also it must have a return type. So it should be return, let's say A plus B when adding the number. So this is the way you can use return. Return must be used at the end of any non-public method, and this is the only valid place for using return statement. So this is for
in the UTXO model. Transaction consists of unspent transaction output or UTXOs. So when a new transaction is created, it usually spend one or more UTXOs and generate a new ones as outputs. So the script context provides a crucial information for validating smart contracts, and it also includes the detail about the version of the transaction, the UTXO being spent, and the various hashing for ensuring the smart contract integrity. So let's go back to the documentation to see how script context actually work. So let's under how to write a contract. So this is script context. So script context is used for validating the smart contract in the UTXO. So as you can see here, this transaction is spending this output. So it is validating the transaction and creating new output. So, and also from version of the transaction up to the signature type, hash type, fields which serve a specific purpose in validating the transaction, and the smart contract can only access the script context in the public methods, and also we can get other information apart from the method arguments, such as the version of the transaction, the UTXO value, the UTXO script, and many more, even the hash outputs. So by building and validating inputs and outputs, our smart contract ensure that this transaction adhere to their predefined logic. So the UTXO, the UTXO value is the amount of Bitcoin
that is spent by the input, and also the script is the locking script of the UTXO. So for the out point, the transaction ID and also the output index of the UTXO, then the hash previous outs provide a hash of the previous output, and also the seek hash and the seek hash type determine which part of the transaction are included in the validation processes. So this is about the script context, and let me give you one example. So for example, this contract designated receivers. So let me just copy it and open my PS Code. So let me first this one. So as we can see, I'm having some issues. So let me just explain the script context. So as we can see, we get the hash output by accessing the script context, and also we can assess maintenance. For example, now the UTXO, the amount that is in the UTXO, for example, I can say const amount equals this dot context dot UTXO dot value. So let me get rid of these errors, as I just copied the code from the documentation. So let me import the let me import them manually. So let's say imports. We can import the smart contract from sCrypt TS. Delete this. Then the properties and method, the address, the byte string, and the, let me make this to be comma, and the hash 256, and even the utils, utility functions. This is supposed to be this dot alice, so there is an error code. This dot alice, and this should be this dot above, and this should provide the amount. Oh, there is no input that. Let me input a sat. Then so I'm importing them manually because I just copied the code from the documentation. So this is how the contract should look like, and you can use many things within the UTXO with the script context. So for example, this dot ctx context dot. So these are the things that we can access: the hash output, the hash previous output, the hash sequence, the log time, the sequence, and serialize. So this serialization allows for the conversion of script context into its standardized format. So this is what script context is all about. So if you want to learn more about script context, you can always refer back to the documentation. So this is just a simple contract that uses script context, that access script context. And what this contract does, it is just distributing 1000 satoshis to two receivers, in this case Alice and Bob. So here I'm going to show you how to access the script context, and this is it. You can easily access the script context to compare the hash outputs of your contract output and transaction output. So in case if you want to learn more about script context, you can easily come back to the documentation. There is a lot of resources to learn from. And also for the seek hash type, this one is very important, and it will be a course of even itself, because it is the one that decided which part of the transaction is going to be included in the script context for the validation. As you can see, we have three types of seek hash type. We have all, none, and single. So For this all means that you should include all inputs and outputs in the validation at the script context. This known that it should include all the inputs without any output. So that means you are putting the restriction on the, you are only sending the input without the output. And this single is showing that you include all the input in the transaction to sign in transaction and the output in the same index. So, and also there is anyone can pay modifier, so that you can allow someone to make some changes to your output. So this is about the script hash. I saw not script hash, the SIG hash type, I mean. And you can even go to wiki.bitcoin.sb and learn more about SIG hash type. So this is all about script context, and there is a lot of resources here in the documentation. You can always come back to the documentation to learn more about script context. So let's explore more about the concept of stateful contracts and learn how to work with them in sCrypt smart contract. So before we dive into the specific, let's understand the difference between the stateless and stateful contract. So in blockchain development, stateless contract do not retain any memory of past interaction. So with stateful contract have the ability to store and maintain data over time. So by default, Bitcoin UTXO model is stateless, and it cannot retain any information, and each UTXO that is being spent is going to be destroyed, and another UTXO will be created. So we have two different type of contracts, that is stateful and stateless. Stateless, that means it will not retain any data, and stateful means that a contract that will retain data, which will keep on updating and retrieving in some subsequent contract calls. So, and let's go back to see how the smart contract maintain state. So for example, now in the first transaction we have input and output. So in the output we have the actual smart contract code and the state. So when maintaining the state, it will, with the help of one built-in function, build state output, we will have a deep copy of all the smart contract code into a new state, which can keep updating on and on. So let's take one example and understand how stateful contract are being developed. So let's copy this one. Let's go back to our VS Code. So let's paste it. So as you can see here, we have a contract counter, and we have one property which is count. So this count property is stateful because it has a parameter of true in the property decorator, which marks stateful property. So this will allow the count property to be updated in some subsequent contract calls, and this makes the smart contract stateful by this true parameter in the property. If this we delete it to be empty, so by default it is set to false, then by writing the true it will make it to be a stateful contract. So as you can see, we have two methods, one public methods and the other one non-public method. So this public method, as you can see here, we use the non-public method that used to update the counter. So after updating the counter, we get the total amount balance in the output. So as you can see here, we use the script context. We get the amount of the UTXO, and also we build a new output here with the help of this built-in function, build state output, which take in the parameter of the amount and build a new state. And here we are checking that the contract output and the transaction output are equal. So if it is not equal, it will give an error of hash output mismatch. So this is how we actually write a stateful contract. So with the help of this true plug in the constructor, we can make it to be stateful, and we can update the state with the help of build state output. So, and also stateful contract have these certain properties, and their values should be updated across different contract interaction. So with this example, we say that the state are being updated, and if you look at the increment on chain public method, this is the public method that cover all the state updates and maintaining the new states. So when you want to write a stateful smart contract, you have to consider the need of your blockchain application. So when choosing a stateful contract, it has to be suitable with your application, which require persistent data storage on the blockchain. For example, you want to build an auction blockchain app or a voting app. So if you want to build like some application that do not retain data, like simple transfer or simple tax that can be validated very easily without retaining any data, so consider using stateless contracts. So let us move on how to understand how to use built-in function. So let's go back to the documentation, and under how to write a contract, still there is built-ins. So we have different type of built-ins. We have global function, we have smart contract methods, we have utilities, and constant. So here at the global functions, we have the first built-in is assets, and this asset is a boolean condition which we either return true or false. So it is just like a require statement, and every public method must have it at the end of every public method. So it will either run successfully or throw a message showing execution failed and tell you the error message that you have inputted. So this aside is very important. It's just like a request statement, and make sure that some condition must be satisfied for you to interact with a contract. In this pill, so pill return an array, but it will be a fixed array, so with the size of element and the value, and this value can be of any type, as you can see here. And also we have some mass functions that will help you do some simple mathematical computation, like the absolute, minimum, maximum, and within. So this will help you to check a number within to check, but you have to make sure that the right is exclusive and the left is inclusive. And the hashing, this one help in the security of your smart contract, so that you will use many different hash methods like SHA-1, SHA-256 to use it with the byte string. Then we can also operate and compute byte string, like converting integer into byte string, and also converting byte string to integer, and also getting a length of the byte string. We can easily use length and pass in the byte string value for you to get the length of that byte string in byte. And you can also use reverse byte string, and the reverse byte string, they are often useful when converting number between little endian to big endian. And bitwise operators like AND or and invert. So these are the global functions, and they are very useful in writing sCrypt smart contracts. Then the smart contract methods, there is compile. This one is used to compile the contract, so that you can use the JSON file of your contract in the artifact folder. And script size, this will help you to get the script size of your locking script. And the load artifact, so this function will log the smart contract artifact from the artifact folder. So by default it will check the artifact folder. Let me show you the artifact folder in the VS Code. So this is the artifact folder. So when you compile a contract, you will have a JSON file of your contract here. Like here I have demo.json. This JSON file is the contract artifact file, that can be used to interact with the contract. So automatically it will check that folder for the artifact. If you load the artifact, use the load artifact function, and it is usually used in the front end. Then check seek. So this function check seek is used to verify a signature, and it takes a parameter of its signature and public key to verify the ECDSH signature. So, and also we have check multisig. This one is used to check multiple signature. For example, you have an array of signature and you want to find a valid signature, so you can use check multisig, as you can see here in this example of pet-pub key hash. So you can see that we have used fixed array and we pass 3 signatures and 3 public keys, and it is iterate to get the exact signature for the public keys. Then build state output. This build state output is very important when writing a stateful smart contract. As you can see, it creates an output containing the latest state. It will also take the input of number of satoshis as the parameter, as an argument. So there is a lot of them. If you need to learn more about the built-in function, you can always come back to the documentation and read it more. And this time lock is also very important when you want to put some constraint into your smart contract with some specific time or date that it should be called. So you can always use time lock. It is very simple and easy to use, as we have an example here. So this is it, and there are a lot of bits from transaction, and this one is used to fetch the latest instance of your transaction. So, and alternatively, you can use sCrypt services when working on the front end, so you don't have to manually fetch the contract instance. So you can always use the sCrypt services. So we'll come to that. So this is the built-in functions. They are very useful and easy to learn, and you can always use the built-in function to automate your work. And also I want to talk on the hash map. And this hash map, there are data structures like hash map and hash set, but in this case they are hash before storing on the blockchain, so that to minimize the transaction fee for storing data on the blockchain. So let me open my VS Code to show you how to use the hash map and hash set. So they are very simple and easy to use. For example, let's use this one as a hash map. Let's copy it and go back to VS Code. So let me paste it. So we have to import the hash map, and let's import it manually. Hash map, and so this hash map, as you can see, we have a map, and it's stored big in. Let me see the arrow here. Okay, it doesn't pass the super, so let me pass super to it. Super. So make sure your contract has this. So as you can see in this map, the hash map contains the key and the value, and the key is big integer and the value is also big integer. We initialize it in the constructor. As you can see here, we have a public method unlock, and we pass in the key and the value, and we set the key and the value to the hash map, and we check whether we have it with this hash, and we also check whether we can get it since it is the hash value of that map, and we can also delete the value in the hash map, and we can also check it if we have it or not. So but at this stage we will not have the data in our hash map because we have deleted here. So this is how you will use hash map. So you can easily deploy and call sCrypt smart contracts on Bitcoin. So after you finish writing your contract, then you can easily deploy and call it. So there are some terms that I want you to understand very well, which are provider and a signer. So a provider is an abstraction of Bitcoin node that give you read and write access to the blockchain, and there is a signer. So it's an abstraction of private keys. It is used to sign message and transaction. So a simple signer is your private key, and a complex signer is just like a wallet. But here we are going to use test wallet to write and to deploy and interact with our contract. So without wasting much of our time, let's go back to the VS Code to write a simple contract and deploy it on chain, so that we will see how to deploy and call a contract on Bitcoin blockchain. So let me go there. So let me delete this. So let's write a new contract and try deploying it and call it on Bitcoin with sCrypt. So let me call it a class. Let me call it demo, since we are on demo project. Yeah, then it should extend the smart contract base class. This is it. Then let's use our post smart contract, which is of hash lock. So let's say hash, so that to understand what we are doing. Should be SHA-256 and constructor. Let's say hash SHA-256 and so far. So we have already write this contract before, so let's use it again to show you how to easily deploy and interact with the contract. So this is hash equals hash. Then let's move on to method, and this method should be public, and let's call it unlock and let's pass a message of type byte string, and it doesn't have a return type. A public method doesn't have a return type. Then let's assert that. No, assert from sCrypt, yes, not from console. Always import assert from sCrypt, yes, not console. Let me delete this. Always import assert from sCrypt, yes, not console, please. So let's say assert from sCrypt, yes, and assert that the SHA-256 of this message should be equal to this dot hash. So okay, else if there is an error, she should tell us an invalid hash. So this is our contract. It's very simple and easy to write this contract with sCrypt. So we can easily now deploy and call our contract the same file. So let me show you how to do it. Async. So the first thing you will do is to compile the contract and load the contract artifact. So here let's load the contract artifact. So we will say wait, the name of the contract is demo dot, then we load the artifact. After compilation, it will generate an artifact in the artifact folder. Then after loading the artifact, we should initialize it. So the instance should be const instance equals new demo. Then it needs a hash message, so let's call it SHA-256. Then let's use to byte string to convert it to byte string. To byte string, let's say hello sCrypt, and it is UTF-8 as you can see here. To byte string literal, if it is literal string, then you should pass a boolean. If it is UTF-8, then you need to pass in true, yes. Then this is the instance. Let connect our instance with a signer. So let's use test wallet as I said before. Then the signer should be signer equals new test wallet, and the test wallet need a private key to sign the transaction and a provider. So we are going to use a default provider, and we use my private key from utils. So let's say my private key, then the provider should be new default provider, and the network should be testnet. So network is bsb dot networks, sorry, not this, bsb imported from sCrypt dot network dot testnet. So we are using it on a testnet, so my private key is having issues, so let me import it manually. What happens to my import? So my private key, I'll import it from, sorry, it is under test folder, utility, private key, yes, here. So it is there. So we have our signer. We can easily connect our instance with a signer. So let's say cons, let's see, await instance dot connect our signer. Yeah, so we connect our instance with the signer, so we can easily now deploy our contract since we get the contract instance, and we connect it with a signer. So let's deploy it. So we deploy cons deploy transaction equals wait instance dot deploy. There is a deploy function, and it takes an argument of satoshis to be logged in the contract. So we are going to log 1 satoshi inside the contract now. So let's write it to the console. Let's say console.log deployed successfully, and we output the deployment transaction ID, deploy transaction dot ID. So let's try running it and see what we will get. So let me save it, and my terminal, let me compile the contract as npx script -cli compile. So let me compile the contract first before running the file, before deploying it. So as you can see, it is building the TS. So let us wait for a bit. So our contract is compiled successfully, and it is here in the artifact. As you can see, we have a JSON file of our contract that we can easily interact with. As you can see that here we load the artifact. So this is the JSON file of our contract. So as you can see, the function is all log, and the parameter is message which is of type byte string, and the contract name is demo, and everything here is here, and this is the certificate of the constructor, the property we initialize, and everything. So this is the artifact, and we can easily run the file to deploy our contract. So let's do it. npx ts not, this is source slash contracts slash, our file name is demo.ts. so let's run the file directly. So we are running the pile, and if everything run without any issue, we will see the deployment transaction ID, and this contract will be deployed on testnet, and we can easily build the transaction data on the what's on chain. So as you can see, this is my address, and I have some satoshis in it. So in case if you don't have a testnet coin, if you are doing it for the first time and you didn't pound your wallet, it will tell you that insufficient UTXO. So you can easily copy the address and go to the faucet and get some test coins at sCrypt faucet. So let me show you how to get the, so go to faucet, sCrypt faucet. So this is it. You can get some test coin here. If you paste the address and click on get BSB, you will get some test coins for free here. So let's go back. Our contract has been deployed successfully, and this is our deployment transaction ID. So let's copy it and build the transaction detail on what's on chain. You can easily open your browser. What's on chain, let's go. So you can easily paste the deployment transaction ID to see the transaction detail. So I don't know why, oh, it's open. So you can easily paste your transaction ID here. Let me paste it and search for the transaction. So this is the transaction detail. As you can see, it is unconfirmed, and we have one input for paying the transaction piece with our address, and we have two outputs. This is for the change output. As you can see, it is the same as my address. So I get some change output for signing for paying the transaction fee, and I have some change. So automatically I will get change output, and for this output of the contract, as you can see, I have deployed hello sCrypt, and here it is, hello sCrypt. You can see the script and hex value of the script. So this is it, and let's go back to deploy and also call the contract to show you the difference. So let's go back and also call the contract, since we have deployed it without any issue. So for you to call the contract, there is another function called methods. We are going to use it here. So let's say transaction, it will be called transaction, which is equal wait instance dot methods, and we call our public method. So as you can see here, our public method is unlock. So you just simply write unlock, and you pass in the function argument. So here is a message which is of type byte string, and so let's hash it with SHA-256, then convert it to byte string, and message deployed already is hello sCrypt. So let's write hello sCrypt, and it is UTF-8, then true. So now we can easily call the contract. So let's log it. So log, so we can see contract call successfully. So let's call the transaction dot ID. So let's save it and recompile the contract, and also the deploy and call the contract. So as you can see, I'm recompiling the contract. So before I have 99790 satoshis, so I have already go to the faucet and get some test coins. You will see my satoshis will be increased when deploying the contract. So let me deploy and call it. So it usually takes some seconds. Okay, this is my address, and you can, this is the link to deposit if you don't have. So as you can see, my satoshis increase already, and the contract is being deployed, and the contract is being called without any issue. So let us see the transaction detail for this one, although it is the same contract. So I want to show you something. So it is the same contract. As you can see, it is sCrypt, and it is the same address that deployed. So let me copy the call transaction and show the difference. So let me copy it and paste it. So here we have one input and two output. So this is the calling transaction, and in the calling transaction you see we have two inputs and one output. So when it is deployed, so the contract is an output, and also you get a change output. That's why you have two outputs and one input, because we are just paying the transaction piece at the input. But here we are spending, we are calling that UTXO, so it is now input here, and we are also paying the transaction piece, so we have the change output as one output. So let me show you the detail here. As you can see, we have script pop key and script seek. So here is the plain text script that we have used as a unlocking script, and this is the script, and this is the hex value. So this is it, and this is how you can easily deploy and call a contract. So this is just a simple contract. You will just play with it. It is very, very simple and easy to write. This will not take even up to 30 minutes. Yes, there will be a situation whereby you want to be interacting with a deployed contract. So you can also interact with a contract that has been already deployed. All you need is get the deploy transaction or the deployment transaction ID. So let's see how to interact with a deploy contract. So here in the documentation there is a lot of information on how to interact with a deployed contract. So let me open my VS Code and let us learn how to interact with a deployed contract. So we have already deployed a contract yesterday. We have write a contract and deploy it. So let's interact with this contract. So let me comment this so that we can, okay, let me save it. So let me compile it, and there is a file here, deploy.ts. So if you create a new project, you will have this file deploy.ts, and the file will look like this exactly. So we are not going to use this. Let me delete it all so that we will write our own deployment script. So let me delete it. So let us see how to actually interact with a deploy contract. So it is very simple and easy to interact with a deploy contract with sCrypt. So first we will import the contract. So let us import the contract, which is demo. We are going to import it from source directory. Sorry, should be contracts. Oh, sorry, should be prop. Import demo from then source, then contracts, then demo. So after importing the contract, we can easily interact with it. So let us a new function main. So let's use a sync and a function. Let's call it main function, and yes, So after that, we have to load the contract artifact. So let's do it this way. So let's load the artifact. Await demo dot. Let's load the artifact. If the contract is already deployed, you will have an artifact here, and we are going to interact with it. So let's say our message, let's declare our message. Once message equals to byte string is from sCrypt, yes. So I think I have to import it manually. Set byte string, it is hello sCrypt, and it is UTF-8, should be true. So let's import it. I don't know, I used to import this thing manually. Let's say to byte string, yes, from sCrypt, and it is to byte string, yes. So this is our script message, and let's our output index to be 0. Cons at output index, let it be 0. And so now let's redeploy it and interact with the deployment transaction only. So let's the demo equals new demo. Let's redeploy it again, and let's sharp 256, sharp 256. Let's pass message here, and I don't have to manually import this, so I don't know what the problem, but you don't have to manually import it. Then after that, we are going to use a default signer. So for this example, let's just use a default signer. So the default signer is at the utility at the test. So there's our signer equals new get default signer, get default signer. I don't think we need new here, just get default signer. And this is a dummy signer, it is used in testnet, so I don't think you, let's import it also, get default signer. So let's import it from utils, under test directory, under utilities, and transaction helper. So after we get our signer, we can easily redeploy the contract and use the deployment transaction to interact with the contract. So let us deploy it. Let's connect our signer with it. So let's connect our signer, our demo. Let's connect it with our signer, which is a default signer. It is mainly used for testnet, for testing purposes. So let's deploy it and see. Cons deploy transaction equals await demo dot deploy. Let's deploy 1 Satoshi. So let's see the deploy transaction ID, console.log deploy. So deploy transaction. So let us see the deploy transaction. after deploying it. So let's say deploy transaction. So let us run it. I have it. This is the file here, so I want to run the file directly, so let me run it. So let us see the deploy trend. So I don't think we are running the file. Let me just write main. Okay, so let me run it again. So it will take a while. So this is the deployment transaction. It consists of everything about the transaction, as you can see here. Let me expand it so that you will see a lot. So as you can see here, we got the inputs, the outputs, the amount, input amount, the output amount, the name, network, which is testnet, and everything about the transaction, and even the version number, the unlock time, and anything about it. So this is deployment transaction data. So in this case, we are going to use the deployment transaction data. We are just on testnet, but you can also use the deployment transaction ID to interact with the contract. So let me let us call the contract with the deployment transaction data, and we can do that with just one line of code. It is very simple to do that with sCrypt. So const call transaction equals await. So let's create an instance before. So let the instance await. We need to declare the instance first. Const instance equals demo, and we will use prompt transaction, and this will take an argument of the transaction data and output index. So let the transaction to be deployed transaction, and also the output index to be that 0 at output index. So let's reconnect the signer, the instance with the signer. So await instance dot connect signer. So after connecting it with the signer, we can easily call the method. So let's call it call transaction equals await instance dot methods, and the method name is unlock, and it needs the script message to unlock the contract. So let's use SHA-256 then message. We already has the message here, so we can log it to our console with the transaction ID. So let us log it. Console log. Console log. Call transaction. And it be called transaction dot transaction dot ID. So let's save it. So we can now easily interact with the contract with the deployment transaction. So as you can see, this is the first instance, which is the demo, and this is the second instance, and it also reconnects with the signer. And as you can see, the instance now is the deployment transaction data and output index, and we can also connect with a signer and call the transaction. So as you can see, we have two instances here. This is the first instance. You can call this one instance again, and instance 1, and we call the other one instance 2 for you to understand the differences. And let's deploy the first instance, and we can call this one the second instance, so that for you to understand. we have two instances here. So as you can see, we have two instances. The first instance deploy the contract, and the second instance call the contract. So let's redeploy it. So let me rerun the file. So let me expand it so that you will see it better. So this is it. As you can see, this is deployment transaction data, and we call the contract with the deployment transaction data, and you can also check it on Watson chain. So testing sCrypt smart contract is very simple and easy, as you will just use one language TypeScript to write the contract and also test the contract, unlike other smart contract language that you will need a different language to write the contract and also another different language to test the contract. And you have to make sure that you have tested your contract before deploying it into production, because if there is any problem, it will lead to fund losses. So, and this is a documentation on how you can test your contract. As you know, we have already write your contract, so we can easily test the contract. So let me just copy a simple test file, and also you can use other testing framework to test your contract, but here we are going to use Mocha to test our contract. So this is the code. Let me copy it. So I have copied it, and let's go back to the VS Code. So here we have a contract. So and this contract is the contract that deploy a hash message, and it requires the hash message for someone to interact with the contract. So let's write a test for it and test the contract to see whether it will work as expected or not. So here under the test directory, we have file demo the test.ts. So if you create any project, you have your own file, and if you already created your own project, you will have it definitely, and open it, and you can also create it. So let us paste it. So let's delete this, and so let me force that one. So we got a lot of errors. So let's import demo from the contract. So let's import our contract. So our contract is demo, and it is from demo file. So we have simply imported our contract, and as you can see here, it is hello world. So no problem, we can use hello world or hello script. It will not be a problem here. And we should also import the other missing dependencies. So let's import 56 and this 56 and 2 byte string, and what else? So let's make this one to be sure, and that's it. So, and also we are going to hash this one too, so that we will have this. Let me try hashing it. So let me save it. As you can see here, we use Mocha, and the first thing we do, we load the contract artifact, and after loading the contract artifact, then we initialize the contract, and we connect it with a signer, which is default signer in this case, and we deploy it with 1 Satoshi, and also call the contract with the right argument. and if everything runs well, it will pass this test. Otherwise, it will throw an error message. And also we try testing it with a run message, since we deploy a hello world message and we try calling it with a run message, so it will also gives an error showing that the hash doesn't match, since it is the hash of the message. So let's try running the contract and see what will happen. So the thing you need to run the contract is npm run test. Npm run test. So it will compile the contract and also run the test file against the contract. So if everything runs well, it will pass the test. Otherwise, it will fail. So let's wait for a bit and see. It is building. Let me expand it. So it is compiled successfully. We have the JSON file in the artifact folder. So it is now running the test against the contract. So let us see. So as you can see here, the contract runs successfully when calling it with the right message, and it fails when throwing a wrong message because we didn't hash the wrong message. So we have to hash the wrong message also. So let's hash it with SHA-256 so that it will also pass and saying that we are passing the wrong message. So let's save it and let's run it again. So one, it passed and also failed, so showing that let's see the error, assert error, since the execution failed, invalid hash. Since our contract we says that if the hash doesn't match, it should throw an error of invalid hash, and this is the error invalid hash. So we now hash the message. So let us run it again. So you just type npm run test, and we're not testing it again. So it is now compiling the contract again, building the TS. So the contract compiles successfully. So it is now running the test against the contract. So as you can see now, the pass method, they should pass the public key method test successfully. It passed, and also it should throw a wrong message with an invalid hash. It also passed. This shows that our contract is working as expected and we don't have any problem with the test. So this is how you can easily test your smart contract with sCrypt, more especially with Mocha testing framework. So let's go back to the documentation to see one or two things. So as you can see that running tests locally without touching the blockchain transaction are constructed with Dumi UTXOs. So the fact that if a test runs on testnet without any issue, so we have confidence that it will also be the same thing on the mainnet, since Bitcoin is pure and it's UTXO based blockchain, not a statable, not account model blockchain. So you can also test a stateful smart contract the same way but you have to keep in mind that stateful contract, the instance used to change when a contract is being called. You have to update the instance. As you can see, this is a counter testing script, and after each contract call, the instance has to be updated. So this is what you will keep in mind, and you can also come back to the documentation to learn more about how to test an sCrypt contract. We can debug our smart contract in two different ways. We can use console log to debug our contract, and we can also use Visual Studio Debugger, Visual Studio Code Debugger to debug our contract. So without waste much of our time, let's continue. So this is our contract, and what this contract does is to multiply two numbers, and whoever provides the product of the two numbers is the one that can interact with the contract. So we are going to use console log to debug it, although we doesn't have any problem in our code, but I will show you how to debug it. So let's compile our contract. This is sync. Okay, then let's compile the contract. Wait, then the name of our contract is demo. Here it is, demo. Let's compile it. .compile. So let's get our instance const demo equals new demo, and in the constructor we have two parameters. That's the value of x and y. So let's pass it here. So as you can see, the IntelliSense, we need to pass the value of x. Let's say 3 big integer, and let's say 2. Okay, so this is our instance. So let's call our public method. Our public method name is what is public. Here it is. So let's say demo dot is public. So what we are going to pass here is the value of z, the product of these numbers. So we have 3 and 2, and the product of 3 and 2 is what? Is 6. So this is it, and so now we are going to use the console log to print out the values so that we make sure that they are carrying the value as we are expecting. So we can debug our contract this way. So we can easily say let's use console log then let's say the z equals, so let's pass the value of z here. So since we pass it the z, this is the public method, and the value of z is 6, so we are expecting the value of z to be 6, and it will print it to the console. So let's save it. Let's open a new terminal, and we have a new terminal. So what we are going to do now is to run this contract. So we can run it by npx TypeScript node Then the file path is source folder, and a contract. This is the part where our file is located. Then the name of our file is demo.ts. So let's run this one. So what this will do, will print the value of z on the console, but I will do a lot of stuff on how to show you how to debug the contract. So it is running. Let's wait for it for a second. We can do a lot of stuff with the console log. So as you can see here, it prints the value of z. So what we are going to do now is to debug the contract, means to know the value of x, the value of y, and are they carrying the exact value as we are expecting. So here we have a non-public method. So let me remove it so that it will not bring distraction. So I just use it in order to show you how to use a non-public method in a contract, so we can do what we like without using the helper contract. So let's say this one will add, sorry, it's multiplication. So what this contract do is just to take two numbers x and y and multiply it. So for us to debug this, we are going to print out console log. Sorry, so the value, let me say just x, is this dot x. So I'm printing the value of x here on the console. So let me print the value of y to make sure that are they carrying the exact value. Then y, then this dot y, then here we have print the value of x, and let's add them together and print it. So let me use console log, then the sum, the product of x and y. So here we can this dot x times this dot y. So as I have already said, this contract take two values and multiply them, and whoever provide the product of that value of that two numbers is the one that can interact with the contract. So here I'm compiling the contract, I'm passing the value of 3 and 2 to the contract, so that means the product is 6. So I'm using console log to debug this contract in order to make sure that the value of x and y are exact the one I set it here. So let me save it and let me run it again. So let me run it again. So as you can see, it print x is 3 as I have passed it here, and the value of y is 2 as I have passed it here. Then z is 6 because 2 times 3 is equal to 6. Then the product of x and y is what? This dot x times this dot y. So this shows you that our x and y carry the exact value as we are expecting them to carry. So with this console log, you can debug your contract to make sure that the parameters are carrying the exact value as expected. So with cursor log, you can do a lot of stuff. You can even print out the script size of the contract and a lot of stuff with console log. So I have you understand how we use console log to debug a contract. And if you have and if you need more explanation about how to debug a contract with console log, you can visit the sCrypt documentation. So as you can see, sCrypt support different front-end frameworks like React, Next.js, Vue, Angular, and even Svelte. So we are going to use React for this video. So let me show you how to actually create a new React project. So this is it. So this is the command for creating a new React project. So let me open my terminal. Sure. So for you to create a new React project, you will first this put your terminal. So this is where this will allow you to create a new React project. With the name of the project will be Hello World, and also it is going to use a TypeScript template. So I don't have to create a new project because I have one. So this is how you will create a new React project. And also after your project has been created, what you will do next is to initialize a script in your project. So first of all, you have to initialize git init. So then git init. So this will actually initialize, I already have it. So we initialize a git in your project, and after that then you git add. After git add, then you commit, git commit, then commit dash m, then let's say initial commit, or you can say paste commit, your commit message. So let's say like this, and after that I already have it. So you also need to initialize a script service, a script into this your project, and you will do that by npx script dash cli at latest in it. So this will initialize an script into your React project so that you can easily compile and interact with your smart contracts. So after creating your React project and initialize a script in it, you get something similar to this. So in this case, my project name is A, just to make it simple. And you will see I have a source directory, and in this source directory there is another folder, contracts. So in this contracts I have hello world.ts, and this hello world.ts is where you will write your smart contract. So I already have one smart contract already written, and let's look at what this smart contract is doing. So this is just a simple smart contract that has two on-chain properties, x and y, and you can only interact with the contract when you provided the sum of that two numbers. So this is a very simple smart contract which will add two numbers, and you can only call it or interact with it by providing the sum of that two numbers. So as you can see, x, which is the type big int, y also big int, and this is my constructor, and also the name of this contracts public method is allloc, and also I have a parameter passed to it which is z, and also it is of data type big integer, and also I assert that z must be equaled the two properties, which is this.x and also this.y. So the sum of these two numbers must be equal to x for someone to easily interact with this contract. So this is the simplest smart contract I have ever seen. So this is very simple smart contract. So in order to make things very easy and simple, so I suggest to use this simple smart contract to show how you can easily interact with the smart contract. So this is my contract. So I have already compiled it, and you can easily compile it by
running npx script -cli at latest compile. So this will compile your contracts, and after your contract is compiled, you will see an artifact folder, and in this artifact folder you have hello world.json. So this is the artifact file of your contracts, so that you can easily import it to your front end and interact with the contract. So after the contract folder, we have another folders, which is app.tsx and index.tsx, and others for the CSS and other few. So let's move to this index.tsx. This is where you will import your contract artifact and also your smart contract file and load the artifact so that you can interact with it in the front end, because you cannot compile smart contract in the front end. So you have to import the artifact of the smart contracts. So as you can see, I have imported the hello world smart contract file, and this is the file path, as you can see in the contracts folder, and also the artifact from the artifact folder. Hello world.json is an artifact file of our contracts, which will be generated after the contract is compiled. And also I have load the artifact, so hello world.load artifacts, and I have load the artifacts. So by default, this artifact will be loaded here, and I have already filled the artifact path here. So I have loaded this artifact, which is in this file. If you look at it, hello world.json. So this is the artifact. So, and this is it in the index.tsx. So we can, so here in the app.tsx is where we have did a lot of work here. So before we explain what the course is doing, and we have to look at something very important in the documentation, and let's move to how to deploy and call a contract. So there are two main important things I want you to understand here is provider and a signer. So a provider is an abstraction of standard Bitcoin node that provide connection to Bitcoin network. So this gives us read and write access to the blockchain, so that in this video we are using default provider and also a signer. So a signer is like a wallet or a single private key that will allow us to sign the transaction. So we are going to use provider that will give us read and write access to the blockchain, or also a signer for signing the transaction. So let's go back and show you how this come into play. So we have a function called interact. So and our provider that will give us read and write access to the blockchain, we are using default provider and on a testnet network. And also a signer, we are going to use Panda signer, Panda wallet, in order to help us to sign the transaction. And after that, as you can see below it, we are requesting an authentication from the signer. So that means that for you to sign the transaction, a signer has to authenticate and confirm the transaction so that the wallet can sign the transaction successfully. So in our contract, if you didn't forget that, we are going to deploy two numbers, and whoever interact with that find the sum of that two numbers is the one that can interact with our contract. So in this case, we are deploying 3 and 4 as the value of x and y respectively. So x is 3 is the value of x, and also 4 is the value of y. If you go back to the contract, you'll see that. So we are actually locking two numbers, x and y, and the user will provide the sum, which is z, and we are going to make sure that this z value is the sum of x and y. So that's it here. We are providing 3 and 4 as the value of x and y, and also connect our instance with our signer, and also we deploy the contracts. And also we use a reference to find to allow user to input the value of x. Let me go down and show you. This is the level. So this is an input, and it refers to the sum, and it is of type number. And if a user input a number, it will be in this sum, and this sum will be the value of z which a user imported, and here we are converting it to a big integer. So this is how we call the contract. So we call it here instance.methods, and the name of our method, if you remember in the contract, the name of our public method is unlock. So we are calling unlock here and passing the value of z to it, and the contract, we make sure that the value of z is equal to the sum of these two numbers. If it is true, then our contract runs without any error. Then if it is not correct, our contract will fail and tell us that execution failed due to incorrect sum. So this is it, and this is what it will render. You see integrate pronoun, and it will allow you to tell you to input 3 plus 4 is equal to, then you write the answer in the input, and also click on the deploy and call button, which will. So after all this, then you open your terminal. Then let me clear the terminal and run npm start. So your project will be started, and it will open in your browser. So let me go to my browser and see what we have already did now. So this is it. It is already running, and this is the result of what we have did. So we are integrating with pronoun, and 3 plus 4 is equal. Then we are going to input 7 and see whether it will work. So as you can see, we are deploying and calling it. So Panda wallet pop up for us to sign the transaction. So the contract is deployed, and we are going to interact with this deployed contract. So we are going to sign in order to call the contract. So it is signed, and this is the transaction ID. You see contract call, hello world contract unlock public method is called, and this is the transaction ID. You can also copy the transaction ID and do the transaction on what's on chain. So click OK and proceed to what's on chain to see what we have just did. So what's on chain. So this is it. Then we paste our transaction ID here and press it, and this is it. We are going to inscribe an NFT and also transfer the NFT by writing a smart contract that will put a constraint on how to transfer the NFT. So the smart contract will make sure that some certain conditions are met for the NFT to be transferred. So in this video, we are going to use a smart contract, a sCrypt smart contract, and this smart contract, we will log two numbers, and whoever provides the sum of that two numbers can easily transfer the NFT. So let's get going. So class of our smart contract, let's call the smart contract demo NFT. So I call it a demo NFT, and it will extend the ordinal NFT base class. So in a regular contract, we used to extend the smart contract base class, but for ordinal NFTs, we must extend the ordinal NFT base class. So we are going to have two properties, since we are going to log our two numbers, and the numbers should be added so that you can easily interact with the transfer the NFT. So let's call the first number X, and it is of type big integer, and also another property, we call it for example Y, and it should also be of type big integer. So we have our properties. Let's initialize them inside the constructor. So constructor, we have X big integer, and also Y, which is of type big integer. Then so far, so
after the so far, we are going to pass the argument in the init. So this dot init, then script arguments, and this dot x equals x, just like a regular smart contract, and this dot y, this dot y equals to y. So oh, sorry, we have having an error here. So this is how we initialize the properties inside the constructor. So, and after that we will have a method, and this method will allow someone to interact with our contract so that he'll provide the sum of that numbers, which is x and y. So the method should be public. So methods, and it will have a modifier public, and this public we are going to call the methods, let me call it alloc, and it will have z, which will be the sum of the numbers, and it doesn't have a return type. So we are going to make sure that the person interacting with the contract will provide that this dot x plus y must be equal to the number z he is providing. Otherwise it will result in an error which will say incorrect sum, because the sum of the contract is incorrect. So this is just a simple contract that will log two numbers, and whoever provides the sum of that numbers can interact with the contract. So this will be like a constraint on how the NFT will be transferred. So let's get going and inscribe our contract. Firstly, we are going to inscribe it with the text. So async function, and we are going to demo the NFT that we are going to load the artifacts. So after the contract is compiled, there is an artifact folder here which will get the ordinal.json, which is our file there, contract. So, and after loading the artifact, so since we are going to inscribe a text, so let the text equal, let me call it hello sCrypt. So this will be the text, and let the instance of the contract should be equal to new demo NFT, and we are going to pass the two numbers, the two properties that we will lock in the contract. So let me call it 2, and y should be 3, so that the sum will be 5, right? So after that, I'm going to connect it with the signer, and in this case let me use default signer. So let me connect my instance with default signer. So get default signer, as you can see it here in the IntelliSense, default signer, and I connect my instance with a signer. So as you can see, after that we are going to inscribe it with a text, as I said earlier. So inscription, let me call it inscription transaction should be equal with instance dot inscribe text. So this inscribe text is a function that will take an argument of the text to be inscribed. So in this case, we have already have our text to be inscribed, which is hello sCrypt, inside a text variable, so we'll just write text. So this will inscribe the text as an NFT. So let me write it to the console so that you will see how it the transaction ID. So console.log, so call it inscription transaction ID. Inscription transaction ID should be inscription transaction .id. So let's run it so that our NFT will be inscribed. So we see the inscription transactions. So let me run the file. So I'm running the file npx node, then this is my file path. So click OK. So I will get the inscription transaction ID. Yes, as you can see, this is the encryption transaction ID. So after getting the inscription ID, I can easily transfer the NFT to any address by giving the sum of that two numbers, since in the constraint of the smart contract that the person that will interact with the public method of the contract is the one that can provide the sum of the numbers. So you can put any constraint on how your NFT will be transferred as you like. So that's the case. So here, let me transfer it. So const the transaction is transfer transaction, and should be equal with instance that methods. My public method's name is unlock, and I'll provide z as an argument, so which should be the sum of that numbers, and 2 plus 3 is 5. So after that, I'm going to transfer it. Let me call transfer and transfer. So this transfer should be a new ordinal non-public non-fungible token pay-to-pub key hash, and this should be OD NFT pay-to-pub key hash. So it's just a normal pay-to-public key hash for NFT. So you provide the address, should be an address. So let me see my address. So I'll use this keyboard. So it should be 2 byte string, and should be 2 byte string. Yes. So I can easily transfer my NFT to this address. So let me write it to the console, the transaction ID if it is transferred. So console.log, say NFT transferred successfully. So with the transaction ID of transfer should be capital T, transfer transaction dot ID. So that's it. So let me save it and let me rerun it again. So let me run the contract. So in this case, our contract will be inscribed and also be transferred, since I'm rerunning it again. Yes, so as you can see, it has been inscribed and it has been transferred successfully. So next, let me show you how you will inscribe an image, since you have now inscribed a text successfully. So let's move on to see how are we going to inscribe an image as an NFT. So let's get going. So for the encryption, I already have my image here in the same folder with the contract. So this is the image, is another work. So let me show you how we do. So the only difference is that here in the text inscription we using this inscribe text, and it only needs some small changes. So firstly, we don't need this, and also we are not going to be using this function anymore, inscribe text. So it should be image. So let me get the image file. So it should be cons image. So image equals the file path. So I will read the read file sync. So you read the file, and also join the path and directory name. So it should be directory name and the image. So in this case, the name of our image is cell 3.png. So this is the image file. Cell 3 is a png file. So and should be to string which is base 64. So should be base 64. So we get the image here, and after that we are going to be using the inscription transaction. Should be instance.inscribe image. So as you can see the difference, in our previous text encryption we use inscribe text, but here since we are inscribing an image, should be inscribe image, and also should be the file path of the image, which is image, and also the content type. So should be content type from sCrypt or the also dot png. So as you can see here, so since our file is png, so that's the only thing you need to change. So I think what we have did is we comment the text inscription, and also get the image file path, the image from the file, and also inscribe it as image, then the file path and the content type. So that's all you need. Then you save your file. So let me clear the terminal. Clear. So let me inscribe the image. So it's the same file. So we are going to inscribe the image now and transfer it also to that address.
Copy the encryption transaction ID to view the transaction detail on what's on chain. So let me copy the encryption transaction ID. So then you can come to what's on chain. What's on chain is a blockchain explorer. You can paste your encryption transaction ID and search for the transaction data on the blockchain explorer. So this is it, and if you look at it, we have one input and two outputs, and under the outputs we have one sat ordinal, which is this, and this is the file that we have just inscribed. So let me expand it, and you can easily decode it. You can decode the actual image that you have inscribed, and this is it. So inscribing image with sCrypt is very simple and easy. And also the sCrypt or the library support fungible tokens which use BSB20 protocols. So, and also we have two different types of BSB20 fungible tokens. We have BSB20 version 1 and BSB20 version 2, which have some differences. So the BSB20 protocol is used for creating fungible token on BSB blockchain, and as the word says, fungible, it is interchangeable with each other and can be used to represent real world asset. So let's start with the BSB20 version 1, which uses tick, and next we will talk on BSB20 version 2, which uses ID. So let's go to VS Code to write a smart contract that we will use to create a BSB20 version 1 token and also deploy and mint it. So let's create a new class. Let's call it hashlock. Let's call it hashlock fungible token ft, and it will extend. So now it will extend BSB20 version 1. As you can see, sCrypt OD library comes with some base classes: BSB20 version 1, BSB20 version 1 pep key hash, BSB20 version 2, and also BSB20 version 2 pep key hash. So we will extend BSB20 version 1, and we are going to pass in the property. Let's say it will be a contract that you will give a script message for you to deploy and mint a BSB20 version 1 token. So let's hash the message. So let's hash it. Let's call it hash, and should be SHA-256. Be SHA-256 from sCrypt, yes. And also constructor, it is just a regular smart contract, but there are some changes. So in the constructor, we are going to pass in the tick, because BSB20 version 1 token is identified by a tick that deploy it. So, and that tick is of type byte string. So let's say byte string from sCrypt, yes. And also the maximum supply, and it will be of type big integer, and also the limit, which will also be big integer, and then the decimal, which will also be big integer, and then the hash of the message, which will be SHA-256. So here it must have a super as other smart contract. Then in the super, we are going to pass in the tick and maximum supply and the limit, then description also only. Then we are going to use the init function to pass in the arguments. So this dot init and split arguments, yes. Then the hash, let's initialize it. This dot hash equals hash our secret message. So let's create a public method for interacting the contract. So method from sCrypt, and public method should be public so that we can interact with it. Let's call it unlock again, and we are going to pass in the message, and this message should be byte string so that we can hash it to compare it with the hash stored hash message. So public method doesn't have a return type, and we are going to assert that our message is the same as the hash message which deploys the contract. Oh, sorry. Assert this dot hash equals the SHA-256 of our message. So our contract is now good. So let's print out an error in case of an error of execution error. Let's say hash are not equal, hash are not equal. So this is our contract, and we are going to deploy it and also interact with it to deploy the BSB20 version 1 token and also mint it. So in BSB20 version 1 we must deploy it before we can mint, while in BSB20 version 2 we can deploy and mint in the same transaction. So let's async, let's deploy it. So async, and also we are going to let our signer be const. Let's use test wallet for our signer. It should be new test wallet, and we are going to pass in the my private key and new default provider. Let me use default provider, and it requires the network option. So let's say the network is BSB from sCrypt.network.testnet. So it should be on testnet. So this is our signer. After getting the signer, let's load the artifact first. This is what we should do first. So hash log empty. Sorry, our contract class, but let's wait it so that we can await hash log ft.load artifact. So when the contract is compiled, we are going to have an artifact folder. It will log the JSON file which contain the contract artifact. So let's declare our tick. Let's const tick equals, it is to byte string. Since it is byte string, let's say something, let's say Doge, as it is there in the documentation. You can check it also, and it should be true. It is UTF-8, and also let the maximum be something of const max equal, it is big int, so let's say should be 10,000, yeah, and let the limit const limit equals maximum supply divided by, let's say 10, and also after the limit let the decimal be 0. So const decimal equals 0. So this is what we have. So let's initialize the instance. So const instance equals new hash log, and it will require arguments of tick. Let's pass it the tick and maximum supply and limit, as you can see it in the IntelliSense. So let's pass the limit and also decimal and also the hash message. So let's say it should be SHA-256, let's say 2 byte string, and let's say sCrypt as a secret message. It should be true. It is UTF-8 encoding. Yeah, so this will initialize it in the contract. So after getting that, let's connect our instance with a signer. So let's await instance dot connect. Let's signer. We have our signer here, test wallet signer, and after that let us deploy the contract. So await instance.deploy token. So in normal smart contract we use deploy, but here we are going to use deploy token, and it doesn't carry any argument. It will deploy our contract, and after the contract is deployed we can easily mint the token. So let's mint some amount. Let's say let's mint some amount. Cons mint transaction equals, let's mint like 10 instance dot mint the amount. Let's mint 10. Okay, let's mint 10 of the Doge, sorry, not 100, 10 is okay. So let's mint 10, and after minting let's log it to the console, that the transaction ID, so that we can check it on what's on chain to see what we have just deployed and how BSB20 version 1 look like. So let's console log and mint transaction is, so as we can pass in the mint transaction dot ID. This is the ID of the minting transaction. So let's deploy this and run it. So let me compile it. So you can compile it by npx sCrypt-cli at latest compile. Then after compiling it, then you can run the pile directly to deploy and mint the BSB20 version 1 token. So let's wait for it a moment. So it is already building the TS. Yeah, so it is successfully compiled without any issue. So let us run the pile. So as you can see, this is the part of the pile holding up the TS, so we can easily run it. So after running it, we can get the maintain transaction ID after it has been deployed, and we are going to deploy the Doge ticker. So it is running. So we have already mint the BSB20 version 1 token. So let's copy the transaction ID and go to Block Explorer to check what we have just did. So let's go to what's on chain. Let's paste it here. So as you can see, this is our transaction. We have one input and two output. This is the input for paying transaction piece, and this is the output for the one-shot ordinal BSB20 version 1 token, and this is the change output. Change output, yes. So if you expand it, you will see that it is BSB20, and the tick is Doge, and the amount we have minted is 10, and the hash message is sCrypt. Here it is. So this is it, and you can get the script and even the hex of it. So this is how we mint BSB20 version 1 token with sCrypt. It is very simple and easy. And also BSB20 version 2 is also similar to BSB20 version 1, but in BSB20 version 2 it doesn't require a tick because the token is identified by the ID. So each token has its own ID, and also you can deploy and mint your token in the same transaction. So this gives you control over your token. You can decide it whatever to do with your token, and you don't have to use tick, because if a tick already exists, you have to change another one. So that is why BSB20 version 2 use ID. So let us go back to see how do we inscribe BSB20 version 2 token. As you can see here in the documentation, there is a lot of information about BSB20 version 2. So you can easily come to the sCrypt documentation to learn more about BSB20 version 2 token. So it is almost the same thing, but as I said before, it doesn't need tick, it only need ID. So let's make some changes to this code so that we don't have to write a new code. So, and also BSB20 version 2 doesn't need limit, so we can easily change this limit to max. Yes, and also it needs symbol, so symbol is byte string, symbol that identify the token, so it also needs symbol. So let's say symbol, and also in the super we are going to change it to ID, symbol, and max. There's no limit. So okay, ID, symbol, ID, symbol, max. So we are going to change the class. It should extend BSB20 version 2. So let's export it so we don't have the error now. Okay, so this is the contract, everything seems good. Okay, so let's come here and see. Okay, it doesn't need limit, so all we need is the symbol and max, then decimal. So we are going to change the tick to symbol. So let's call our BSB20 version 2 token sCrypt. It should be sCrypt token, and the instance also needs no limit. The instance also don't need limit, we only need symbol, max, and ID. So we can say here to byte string. Okay, sorry, let me delete this. I'm some error. So to byte string, this is for the ID and also the symbol. Okay, so it seems good. And in BSB20 version 2 we can, yeah, okay, the sCrypt message should be sCrypt also, so we don't need to deploy the token. We can deploy the token, but we don't need to mint for now. Let's deploy it and get the token ID, then later you can transfer it, because you can deploy and mint it at the same time. So not like BSB20 version 1 that we have deployed it and now we are minting it. In BSB20 version 2 you are deploying and minting it at the same time, and you can transfer it also. So let the token ID, instead of token mint transaction, let it be token ID. Token ID equals to await instance dot deploy token. Yes, let's copy this and paste it here. Okay, and we need to also log the token ID, not the mint transaction for now. Let's say token ID. Let's call it token ID. So token ID dot ID. Okay, should be token ID doesn't have ID, which is the deploy token. So this is the difference between BSB20 version 1 and version 2. As you can see here, we need ID and symbol, while in BSB20 version 1 we doesn't need that. and it extends BSB20 version 2 base class, and in the instance we only need symbol maximum and decimal, and also the secret message, and we can just deploy it and mint it at the same time. So let us deploy it and see what we get. So let me save the file, let me expand the terminal, and let me compile the contract. npx script -cli at latest compile. Then this will compile your contract, and we can get the JSON file in the artifact folder. After compiling the contract, we will run the file and we can get the token ID. So it has now compiled successfully, so we can easily run the file. This is the file, as you can see, npx ts not, then the file path. So let's run it and see. So the file is running. This is my address, and this is my balance, and this is the token ID. So the token ID is the deployment transaction ID and a suffix of output index, which makes it to be an out point. Let me copy it, and so for you to get the transaction detail about this token, you should paste this one and delete the preceding 0, and search for it. As you can see, this is the transaction, and this is my address, and this is the output, and this is the one set order. As you can see, here is BSB20 version 2, and it is deploy and mint, unlike BSB20 version 1 that is only the deploy, that is only mint, and the symbol is sCrypt, and the amount we mint 100,000, and the decimal is 0, and this is the secret message. So the amount is here, we make it to be 100,000, so you can input whatever amount you want it to be. So this is just a simple illustration on how to inscribe a BSB20 version 2 token. So we have many tutorials under the tutorial tab. As you can see, we have almost 9 tutorials. So let's explore tic-tac-toe. So tic-tac-toe is a game which we implement on Bitcoin. So it is a very good game to play, and it is very simple and easy to actually write the smart contract with sCrypt, and it is very good for beginners to try it, because they will learn many concepts with the tic-tac-toe game with sCrypt. So we have the code complete here. So let me copy the code so that we can explain and implement it. So let me copy it and move back to my VS Code. So let me press the contract. Oh, a lot of errors. So because we didn't import anything, so let me import them manually. So let me import the smart contract, and let me import the property decorator, the method, the pop key, pix array, import field, and asset, and the signature, and let me see other dependencies. So to byte string, so let me to byte string, POKey to address, and utility function. So I have to import them manually here because I just copied the code from the documentation. So I will also import #256 and we will be okay. So #256. So we are good now. As you can see, we have a very good smart contract without any error. As you can see, our smart contract name is tic-tac-toe, and it extends the smart contract base class. So let me explain what this tic-tac-toe game is all about. So we create an interactive and decentralized game using sCrypt, which is this tic-tac-toe. So as you already know, tic-tac-toe is a classic game enjoyed by all people of different ages. So in our implementation here, we leverage the power of sCrypt to write the smart contract of a secure and transparent game where two players, in this case Alice and Bob, can lock their bet into the contract. Then the winner takes all the Bitcoin. While in an event where a draw occurs, both players can simply withdraw their money back. So as you can see here, we have the properties, and we use sCrypt decoration to mark our properties, like Alice here and Bob, which represent the public keys of the players, and it's Alice's turn to keep the track of who is in turn to play. And additionally, we use pick size array to represent the game state. As you see, it is a bot, so that it can represent the game state, and also this static to represent when the board is empty and when it is 1, so that it will be Alice to play. When it is 2, then it will be Bob to play. And in the constructor, here in the constructor, we initialize the contract with the public keys of Alice and Bob and set the initial game state to an empty board. So as you can see, we initialize the public key of Alice and Bob, and also set the turn to be true for Alice, and also fill the board to empty. As you can see, it is empty, which empty is 0. Yeah. So, and also we have public method move, and this public method move allow players to make their moves in the game. It takes the index of the square and the player's signature as parameter. As you can see, the index n and also the signature, it is the parameter of the public method. So we will use this signature to ensure that only the intended player can make move. So if the player is not intended to make move, it cannot make move, because it will check the signature of the public key to make sure that it is the intended player that is making the move. And also we have non-public methods. We have 2 non-public methods, won and pool. So the non-public methods won and pool, they are to check if a player has won the game or if the board is pool, as you see respectively. So these 2 non-public methods, they determine the outcome of this game. I hope this code is explained. So let us simply deploy this this smart contract for tic-tac-toe. So let us deploy it on chain to see how it will work on chain. So let's go sync. Yes, let's deploy it here in the same file so that it will make it easy for someone to understand. So let us load the artifact. So tic-tac-toe dot load the artifact, and after loading the artifact, we will, let's say, the signer, we use the signer to be test wallet. I usually use test wallet, so should be new test wallet. And the test wallet needs an argument of my private key, and also the provider. So I will use default provider, new default provider, and network should be testnet because I'm working on testnet. So bsb from sCrypt dot networks dot testnet. So after that, let me initialize the instance. So I will initialize the instance const instance equals new tic-tac-toe. Then it needs an argument of Alice public key and also Bob public key. So let me declare the public key of Bob and Alice. So let's say Alice pub key and Alice pub key, then address, and I will get the pub key from random private key. I will import them random private key. I think I should import them manually, so let me import them from helper, transaction helper. So let me import random private key should be from test utilities and transaction helper. So let's go back to C. Yeah, so we import the public key there, and let us declare the also both public key from the same random private key. So let's say both. So the reason why I put this comma, so the first parameter here is the private key. When you generate the random private key, here will be the private key, then here the public key, and also the address here, and then woofer. So here I have get the pub key of Alice and Bob. So let me initialize them. And the pub key, let me to hex, then Alice pub key, and also another pub key, also to hex, and this time it will be Bob public key. So this is our instance. So now we can easily connect our instance with a signer and deploy the contract. So let's wait instance dot connect signer, connect signer. So when our instance is connected with the signer, we can easily deploy. So, and the deployment function need an argument of amount to be logged in the contract. So let the amount be 10 satoshis, const amount equals 10. So let us deploy it. Const deploy transaction equals await instance dot deploy, then pass in the amount as argument. So it will log 10 satoshis in the contract. So let's log it. Console log deployed and we should see the transaction ID, deploy transaction.id. So let's try running this. Let me save it and let me open the terminal. Let me compile the contract first. So you compile the contract always with npx sCrypt-cli at latest compile. So this will compile the contract. Then after the contract is compiled, we can easily call the file to deploy the contract. So let us wait for a bit. As you see, it is already building the TS. Okay, great. So let us deploy, call the file. As you can see here, we have our file name is demo.ts. So npx ts node and the file path. So let us run it to deploy the contract. So if everything runs without any issue, we shall see the deployment transaction ID. So as you can see, the contract is deployed. We can easily copy the transaction ID and go to what's on chain to fetch the transaction ID. And this is it. You can see this is the output, and everything is here. And also, for you to understand the full decentralized tic-tac-toe game, you can go to our sCrypt Academy. We have a comprehensive course for learning sCrypt in an interactive way. So this is sCrypt Academy. It makes learning sCrypt easy and enjoyable. As you can see here, we have 4 different courses, from the tic-tac-toe game, how to inscribe the ordinals. It is also a course. Build zk Snag based battleship game on Bitcoin, which use zero knowledge proof. And also you will learn how to build a full stack voting dApp on Bitcoin with sCrypt. So this is sCrypt Academy. You can come here for an interactive learning with different courses. And also we have a lot of contracts along with their thesis in our boilerplate. This is our boilerplate, and you can check the contracts. So we have different kind of contracts which you can play with, and also together with their thesis. And this is the test folder. Each contract has its own test, so you can run the test against it to see how it actually works. And also, if you have a question and need to know more about sCrypt, you can easily visit the official site of sCrypt, where you will have the link to all our channels: Discord, Slack, GitHub, Telegram, YouTube, Reddit, and Twitter. So thank you for watching. Happy coding.